Let's review our friction and force homework. We see right underneath friction and force the formulas to use and a few definitions. F is force in, how hard you pull, pounds on a pull scale, or in our case we've been using kilograms. R is force out, scientific weight, or newtons, 10 times the weight or the mass in kilograms. Let's go ahead and look at the first problem. To help my mom move a box from the kitchen to the door, we placed it on marbles, mu equaling 0.06. If my box weighed 50 newtons, how many newtons of force did I need to move it? We will be using this formula because we have the mu and we have the R, the scientific weight of the box. So we have the mu and the R that we can multiply together to give us the F, the force we put in. So in our formula box here, we will move our formula down. We can see that F equals 0.06, the mu, times 50, and that equals 3. So it took 3 newtons of force to move a 50 newton box if it was on marbles. The second question here, we put grease on the marbles and a 160 newton weight on our board. The pull scale read 8 newtons. What is the mu, also called static friction? In this problem, we have the weight of the board, or the weight put on the board, and we have what our pull scale read. So, we have both the F and the R, but we do not have the mu. That is what it is asking for. So we will be using this second formula. Let's go ahead and plug it into our formula box. Now we can see that F, being the force in, which is 8, if we divide that by 160, which is R, the force out, then it will give us the mu. And in this case, greased marbles apparently have a hypothetical mu of 0.03. 0.05. If we notice here, in our third problem it says with the greased marbles, and you needed to fill in 0.05 now that you've figured that out, and a weight of 3,600 newtons. How many newtons of force does it take to pull the weight? This time we have the mu and the weight, okay, and it is asking how many newtons of force does it take to pull the weight. So we won't be using this third formula. Okay, we actually have the mu and the weight. Okay. So this time we will be using the first formula again. Okay, F equals mu times R. We have the mu of 0.05, we figured that out in the last problem, and we have the weight, the R, of 3,600 newtons. So if we multiply those together, we get an answer of 180 newtons. It took 180 newtons of force to pull the weight. So you can see we did not use the R equals F divided by mu for any of our problems. We used the first two formulas for these three problems. If you have any questions about the homework, just let me know.